let's try to solve another Leetcode problem. 1171, remove zero sum consecutive nodes from linked list. So the idea is that we are giving this kind of a linked list. So for example, 1 plus 2 plus minus 3 is going to be 0. So this means we're going to remove it. So after all, we're going to return the head of the linked list. It's going to be 3 and 1. And for the second case is that this 3 minus 3 is going to be 0, and we just need to return 1, 2, 4. And for the third case is that let's just find maybe this is 3 minus 3, 2 and minus 2 is going to be 0, so we just need to return this 1. So how can we solve this problem? So the node is going to be 1 to 1000, so it seems okay. Even we solve it in ON square, it should be okay. But for this time, I'm going to use ON solution. Actually, this is going to be a really good solution for such kind of problem. So I'm going to use a dictionary to solve the problem. And the idea is that we just need to find all the numbers. The sum of the values is going to be 0, and all the numbers are going to be consecutive. So if it is consecutive, maybe we're going to use the prefix sum to solve the problem. Yeah. So let's just use the prefix sum idea. So the global idea is like that. So this is our linked list. So I'm going to turn it into an array because it's the same. So from some places, maybe here, we're going to have a value. So the prefix sum of the value is going to be 3. But in between, there's going to be the prefix sum, and until some other places, maybe here. Yeah, so this position is A, and another position is B. So the value gonna still be 3. So this is the prefix sum of 3. This is another prefix sum of 3. So what is the meaning of that? So this means from here, from this position A to B, in between, the sum of the values gonna be 0. So this is just the basic idea. Let's just use the first example to explain it. Yeah. So for this example, we have 1, and the next number gonna be 3, and the prefix sum gonna be 0, and for the next one it's gonna be 3, and for the next one it's gonna be 4. So this is a 3, and this is another 3. So what is the meaning from here? Yeah. So this means this is a 3 and this is another 3 according to the prefix sum idea. So this means yeah, if they are equal, it means from here 0 to 3, those two positions are going to be 0. So this is exactly like minus 3 plus 3 gonna be 0. So this is the basic idea. But for us, we're going to prepare a prefix 0. So this is easy for calculation to find all the different cases, because this 0 is important information which we need. So this is why we're going to prepare a prefix 0. So if we have a prefix 0, now we have another 0. So this means from here 0 to 0, and the sum of the values are going to be 0. So what does this mean? This means for the first 3 numbers it's going to be 0. So this means 1, 2, and minus 3. It's going to be 0. Yeah, the sum of the values is going to be 0. So this means we can use a dictionary to update the values. So in this example, if we find a value, it is 3, but after some calculations, when it goes to here, when it loops to here, we find another value 3. So we need to remove the information from here because this is not important anymore. We just need to record this information. This is 3. So for example, there's a maybe there's a node 1. So for the next position, it's going to be ported to this node 3. But we don't need this node anymore. We just need to use another node. So it's going to be this node dot next. Maybe there's a node 2. Yeah, after this 3, there's a node 2. So this means between those areas, the sum of the value is going to be 0. So those informations is not important. So this node 1 is going to be ported to another node. It's going to be this 3 dot next. It's going to be the node 2. So this is the basic idea of how can we use a hash table with prefix sum to solve the problem. Yeah. So as we can see from here, so this node is 3. This is another 3. So for a node, for example, here I have a node 1. So node 1's next is 3. But in between the prefix sum, is 3, and this prefix sum is also 3. This means in between these areas, it doesn't matter because the sum of them going to be 0. So 1 going to be ported to 2. So let's just use this example maybe. Yeah. So this is a 0, and this is another 0. So for this 0, we're going to update the value. So let me just make another drawing maybe. So I'm going to use this prefix sum to update the value. So first of all, I'm going to prepare a dictionary. So for the first value, it's going to be 0. I'm going to prepare a padding with 0. So 0 going to be the k, and the values going to be the node. So first node, it's going to be a dummy node. So I'm going to use a 0 dummy node as my first node, or maybe I can use some others. Maybe, yeah, because I want to prepare a dummy node. So this is going to be a dummy node for this value 0, and next it's going to be 1, the prefix sum. So for this 1, what's going to be the node? So it's going to be the node 1, going to be the value, and then we're going to check the next. It's going to be 3 because 1 plus 2 is going to be 3, and the next node going to be 2, and then we just continue, and the next it's going to be 0 because 3 minus 3 is going to be 0. But as this is a dictionary, we need to update this one. So currently it is not the dummy node anymore. So it's going to be another node which is going to be minus 3. Yeah. So for the value 0, the value going to be minus 3. So what about 1? It's going to still be 1. Let's just continue to finish the last one. So it means it is 4. So 3 plus 1 is going to be 4, and the node going to be 1. Yeah. So this is the basic idea of solving this problem. As we know, some of the informations are going to be deleted. So for example, this is 0 going to be ported to dummy node, but now it's going to be ported to this minus 3. So the value for the k 0 going to be minus 3. Yeah. So this means the previous information, it doesn't matter. Yeah, I just need to start from here. Yeah. So for this node 1, it's going to still be 1, and for this for the value 1, it's going to be node 1, and for value 3, it's going to be node 2, and for the value 4, it's going to be node 1. So what are we going to do next? We just need to prepare another iteration of the linked list, and we just continue. So from the beginning, it's going to be 0, but this is 0 going to be ported to the value to this node minus 3. So we're going to check the next. So minus 3 dot next. So it's going to be the value 3. So this is going to be the first node. Yeah. And then we're going to continue to check the next. So for the next 0 plus 1, it's going to be 1. It's going to be this node 1. And we're going to still use the prefix sum. So it's going to be the node. It's going to be 3 plus 1. It's going to be this node. It's going to be the value 4. So 4 ported to a node 1. Yeah. Yeah, let me just check. Yeah, so first of all, it's going to be this node 3, because minus 3 dot next is going to be this node 3, and then we're going to continue to check the next. So the next going to be the prefix sum. It's going to be 0. Yeah, so the prefix sum going to be 3, and maybe I need to start coding to explain it. Maybe, yeah. So this is gonna be so this value this node gonna be 3, and then we're gonna continue to use the prefix sum. So the prefix sum currently it is 0. So for the next one, the prefix sum gonna be updated to p dot value. So the p gonna be this node 3 dot value gonna be 3. Yeah. So for the next value, it's gonna be 3, and p dot next it's gonna be this 3.next, it's gonna be this node 1. This means the node 3 gonna be connected to node 1, and we're gonna continue to check. Yeah. So currently this p gonna be equal to 4, and then we're gonna check the node of the value of 4. So the k, we're gonna check the k. So the k is 4, and the value is node 1. And what about once next? So once next is none. So it means the next node gonna be a none. So this is the basic idea. I think we just need to understand what is the prefix sum, and basically, yeah, if the values are equal, if the keys are equal, the prefix sum are equal, we just need to update the values, because the previous information doesn't matter. We just need to keep the latest information, and then we just need to use another while loop to check to connect them together. So the first is just to, for example, yeah. So the first is for something, here is a 3 and here is a 3. So we just need to update the dictionary. And the second one is that we just need to connect them together. So because this is equal, so this means in between it's going to be 0. We just need to use this node to connect to the next node. It's going to be 3.next. Yeah. Now let's just use this kind of idea to solve the problem. So I'm going to prepare a dummy node. So the dummy node gonna be a list node. So the next gonna equal to the head. And now I'm gonna prepare the prefix sum and pointer p. So the prefix sum gonna be 0, and p is gonna be the dummy node. Now we can loop through the pointer p. Basically, we're gonna start in from this dummy node. So the prefix sum gonna update to p.value. And then we're going to update the dictionary. So we're going to prepare a dictionary. So the dictionary is going to be a default dict, and inside the value, it's going to be the list node. Now we're going to update the dictionary. So it's going to be a pre-sum, and the value going to be this node p. And after that, p going to equal to p.next. So this is going to be the first loop. So this means we've already updated the dictionary. Now we just need another while loop to connect them together. So the second while loop is that we're going to still update the prefix sum. Yeah. So for the first example, if we have some value, the prefix sum is 3 and another is 3, but we've already updated the dictionary because the dictionary only records this information, and this node 3 and after that. And for the second loop, while we find this node 3, actually, it doesn't matter. We will not check it from here. We will directly check it from here. And we're going to check this node and this node not next. It's going to be exactly the information we need, because everything in between is going to be 0. Yeah, so this is the basic idea to solve the problem. Yeah, because from here, this is the same value. So let me maybe just use this example. Yeah, so from here, it is 0. The prefix sum like 1, 3, 0, and 3, and 4. So here is a 0. Basically, here we find another 0. And we have a dummy node. It's going to be the node 0, for example. The dummy node is 0. So what is going to be the next? While we find this 0, we will not go to the next, which is this node 1. We will ignore these areas. Basically, we're going to check this node 0 and this node dot next, which is going to be node 3. This is why this 0 node is going to be connected to 3, and the the prefix sum, this is 3, but actually the value is going to be 3. But for the next one, the node is 1. Yeah, so this is the basic idea. Now, we're going to update the p.next. So from here, so p.next is going to be equal to, we're going to find this node by using the dictionary, and we're going to check the next, this node dot next. This is what we need to connect. And then we're going to update the p going to equal to p.next. And finally, we're going to return dummy.next. Yeah, so this is the idea to solve the problem. Yeah, it seems there's something wrong. Let me check it. So yeah, so for the next loop, I still need to prepare another prefix sum and the pointer p, otherwise I cannot find the position where it is. So this is the first position, so let me just copy it from here. Yeah, and the second loop, I still need to prepare the prefix sum and the pointer p. I just need to use another loop just to connect them together. Let me just run it. As you can see, it works. Now let me submit it. Yeah, as you can see, it works and it's pretty fast because this is a on time and on space complexity for the problem. Thank you for watching. See you next time.